Let's specify exactly when you can use the normal deviate test, the z-test. The main thing that you need to know is you need to have information about the population. You need to know the mean of the population, mu, and the standard deviation of the population. And you have a sample that you want to test to see if it comes from the above population, to see if it's different from the population mean and standard deviation. Now, this seems like it would be something that occurs fairly often, but actually, very rarely do we have the standard deviation of the population. So the z-test is mainly taught because it's the easiest of the inferential tests that we're going to be looking at. We're going to see later that the t-test is far more common because you don't need to know the standard deviation of the population. But we're starting off with the z-test because it's conceptually the easiest. Now let's take an example using Beanie Babies and how cute Beanie Babies are. In this example, we want to ask the question, the research question, are Beanie Baby dogs cuter than the average Beanie Baby? And then what we're going to do is we're going to formulate our alternate hypothesis. We're going to have to decide if it's one or two tails. Then that will allow us to formulate the null hypothesis. Then we need to select a random sample of n dogs and calculate the average cuteness. And we already have the cuteness for the population. That was actually because I defined how the distribution was going to go. In measuring the mean of many Beanie Babies, hundreds of Beanie Babies, I gave people scores where the mean had to be 5.5 and the standard deviation 2.5, and that's how I was using that same system for the others. So we know what the mean and the standard deviation is for the population. And then we're going to use that information, the mean that we obtained from the sample and the population information, to calculate the z-statistic obtained from the sample using this formula. Then we'll calculate the p-value of z obtained, and based on the p-value, we'll reject or retain the null hypothesis. Low p-values mean that we reject the null hypothesis. High p-values mean that we have to retain it and say, oh, we don't know. Now, in the Excel example, in the next video that I'm going to give you a z-test calculator where you'll have to fill in the population mean and the population standard deviation and the raw scores here, and then the calculator will do all the rest. It'll count the number of scores that you have in the cuteness column. It'll calculate the X bar, the average that we obtained from the sample. It'll calculate the z-score, and it'll calculate the p-value for both a one-tailed test and a two-tailed test. So we need to determine before we carry out the calculations, and it has to be before, otherwise it's unethical, whether we want a one-tailed test or a two-tailed test.